Good day, children of Enriched Geometry. We are moving on to tangents. So we're kind of beefing up our properties about circles. I feel like the first half of the chapter, it's all pretty like intuitive to a point where it's like, oh, I can remember this. This makes sense. This is easy. And now the second part, we're gonna challenge you a bit more, but that's okay. It's still good fun. Okay, so today we are going to learn what a tangent is. Then we're going to learn some properties about tangents to help us find missing values, kind of like the same old thing that we do every time. We're going to learn some properties, and then it's going to help us solve for missing values. So let's talk about what a tangent is. So a tangent line intersects a circle at exactly one point. We call this the point of tangency. So if we see this, you guys see how we have line AB here. It is tangent to our circle because it only touches it in one spot, just barely just nicks it, right? So point A here would be our point of tangency. All right? A line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So basically, wherever your line is tangent to your circle, it's creating a right angle, okay? And this will be key information to know later on when we're solving problems involving tangent lines. So big takeaway here is a tangent line touches your circle once, called the point of tangency, and it's perpendicular to its radius, okay? So our first job is let's determine if segment AB is tangent to circle P. So we are trying to figure out, is this a right angle? Well, how are we going to determine if that is a right angle? Well, we could pretend that it isn't a right angle and then see if it's a right triangle, right? Because, right, we love to use the Pythagorean theorem. So we can see if it works, and if it works, it would be a right angle. So we're going to have 8 squared plus 15 squared, but since I don't know if it's equal or not, I'm going to leave it blank. It's equal to 17 squared. And now we'll just kind of crunch out these numbers. We know 8 squared, 64, 15 is 225. Again, we don't know if it's equal to or not, so we're going to leave it blank. It's 289. 64 plus 225, ooh, folks, is indeed 289. So you guys see how we got 289 is equal to 289. So this indeed is tangent because it's a right angle. So we're going to say yes, AB is tangent to circle B. But just to pretend, let's pretend we didn't. Let's pretend that we got 301 here. Is 301 equal to 289? No. So then you would have said no. Does that make sense? So they have to equal each other. If we would have got something that didn't equal 289, that would have been a no. But in this case, it worked. So that's exciting. Good job. All right. Next. Says, find the value of x, assume that segments that appear to be tangent are tangent. Okay, so in this picture here, we are allowed to assume that segment BC is tangent to our circle. All right, so we can assume that's a right angle. And now we're just looking for x. So again, you guys, it's just Pythagorean theorem. We have a right triangle here. So we're going to have 14 squared plus x squared equals 17 squared. Now we'll just crunch out these numbers. 14 squared is 196. 17 squared is 289. Subtract over. Take the square root. X equals 9.6. And we're done. So not too shabby. Okay, this next one, we're beefing up our algebra. which is good because you're all moving on to Algebra 2 next year in a few short months. So it's good that we are practicing these skills. Okay, same instructions. We are allowed to assume that segments that appear to be tangent are tangent, and we're looking for x. So we are allowed to assume that SQ is perpendicular to QR. So again, we have a right triangle. But now our new problem, our current issue is, well, what the heck is QR? I don't know what QR is, right? Like, what is this length? Okay, you're smart. Remember, all radii in a circle are the same. So if this radius, is x, then so would this one be. So that's x. And the other thing you need to be smart about, children, is how would I represent this amount here? You did it right. You're so right. X plus 2. That would be that whole length. Or 2 plus x. I just like to write my variables first. So now we can do our Pythagorean theorem. We're going to have 4 squared plus x squared is equal to x plus 2 squared. Okay, here we go, folks. 4 squared is 16. We're looking for what x squared is. Okay, I know this is what you're going to want to do. I know you're going to want to do this. Oh, that's just x squared plus 2 squared. No, that's not right. Don't do that. Please don't do that. We're smarter than that. We're better than that, people. Remember, this means you're taking it times itself. Yeah. Guess what we get to do now? We're foiling. Everyone's favorite. Foiling or double distributing, whatever you want to call it. So we're going to take x times x and get x squared. X times 2, 2x. Now go through with your 2. 2 times x, 2x. 2 times 2, 4. Woo! I love it. It's good to work your brain. You need a healthy brain to function. Okay, let's combine some like terms here. X squared is just x squared. But what's 2x plus 2x? It's 4x plus 4. Okay, good job. And now this looks kind of gross. But good news, it's not gross. I have an x squared and an x squared, so they'll say see you later. So now we have this. That's what we're left with. And now it's just a linear equation that you guys are all used to solving. Bring your 4 over. Divide out. X equals 3. Oh, amazing. We did it. Good job, team. We did it. That was fun. That was a lot of fun. Okay, we have 2 more properties that involve tangents. Let's talk about them. The first one is, if 2 segments from the same external point are tangent to the circle, then they are congruent. So let's break it down. Here's my external point B. And do you guys see how AB is tangent to the circle, right? Because it touches it once and it's perpendicular to the radius. And same thing over here. BC touches your circle once and it is perpendicular to your radius. If this situation happens, then we would know that AB is congruent to BC. So like 5 and 5, they are the same length. Okay? The second property that we need to keep in mind is if we have a polygon that's circumscribed around a circle, then all sides are tangent. So remember, circumscribed means that it's on the outside. So we have a polygon on the outside of our circle. And what's happening is all of these points here where your circle's touching your triangle or the other polygon, they're tangent. Why is that important to us? So that would mean that DB is equal to BE. EC is congruent to FC. And the other color, I guess we'll use black here. Then AD is congruent to AF. I would probably make those marks on that picture so you remember. Or if you're like a number person, this is 3, this is 3. This is 2, this is 2. This is 6, this is 6. I don't know, I made those numbers up. But that's what that means, you guys. It breaks those parts into equal pieces. Okay, it says find the value of x, assume that segments that appear to be tangent are tangent. So we have this situation where we have our external point, and we can assume since CB is only touching our circle once, and same with AB, then that these two expressions are equal since those segments are congruent. So we just get to set them equal to each other and solve like we've been doing. So bring your variables to one side, your numbers to the other, and divide out. So we simply find that x is 14. Easy peasy. Not too much to do there. And then our last one's kind of fun. Again, I like puzzles. It says find the perimeter of quadrilateral PQRS. Okay, we got this. So we're looking for the perimeter, but we're missing some chunks. Like, what the heck is this length? And what the heck is this length? We need to find those in order to find the whole perimeter of our quadrilateral. But we know what to do. Yes, you do. I know you do. So remember, all these points here are tangent, so that's going to break our perimeter up into equal congruent little pieces, okay? So remember, if this chunk is 23, then so is this chunk. So now if I know that chunk is 23, what's left over of our 37.5? So 37.5 minus 23 should give us 14.5. So now I know that this is 14.5. And now that I know that that's 14.5, folks, look at this. 14.5. So we found that missing piece. Now keep working. So now if this chunk is 27.1, we know that up to here is 27.1. But then we're going to have to subtract 27.1 from 52.5 in order to find out that this piece here is 25.4. And now that this piece is 25.4, so is this one. Wow! We did it! We found all the missing chunks. And now we can easily find our perimeter. So I'm going to use the top PQ as 37.5 as that whole side, plus 14.5, plus 27.1. This bottom side of SR is 52.5. And then we had 25.4 that we had to find, plus 23. Add all those numbers up, folks, for me in your calculator. And you should get 180. I love it. It's a good day. It's always a good day, but it's a great day. And that's all I have for you. Okay? Good work. Thanks for watching. Thanks for being you. Be good. Wear your seatbelt. Onward Central. Goodbye.